Hello everyone, I am Anurag Sharma, currently pursuing BTech in Computer Science Engineering from NIT Silchar, and currently I am in my fifth semester. And from now, I have decided to solve lead code daily questions. Okay, so let's move on to solve our new today's question. So today's question is, we have to find the minimum common value. It is marked easy on lead code, and we are given two integer array. Let's first of all understand what the question says, that we are given two integer array nums1 and nums2, which is already sorted in a non-decreasing order, and we have to return the minimum integer common to both the arrays. Question is self-explanatory. It in We are given two arrays, and in which we have to find the smallest minimum array. So yeah, this is the question. Like we can see the test cases. In the very test case, it is given this. The number is 1, 2, 3, and the nums2 is 2 and 4. So the smallest element common to both array is 2. So we return 2. As and in the second question, and then second test case, our nums1 is 1, 2, 3, 6, and nums2 is 2, 3, 4, 5. As usual, the one is not the one is the smallest but not the common in both of these arrays. As so 2 is the smallest and 2 is the common in both the arrays. So this is the way in which we have to return our answer. We have to return the that element, particular element of that array. So okay, so let's move on to how we will solve this question. So basically this question can be solved by using two approaches. We can solve this question in two approaches. Okay, so the first approach is by using set unordered set. We can use an unordered set, and the second approach is we can use a two pointer approach. So we will solve this question from both methods. Okay. So first of all, let us solve this question by using an unordered set. Okay. So what will we do? We are given any number 1, 2, 3, 4, nums1 and nums2 with 2 and 6 and 8, suppose. So we will fill the set with one array. We will completely insert all the elements of that array into the set, and then we will iterate through the second nums, and it means the second array, and then we will find whether this element exists in this set or not. If this exists, then we will return the array. Then we will return the answer. If not, and if the iteration is complete, and if we have not found our desired element, then we will return the -1. So this is the basic approach, and we can talk about the time complexity and the space complexity of this approach. Time complexity will take you big of n, because we are going to iterate each and every element of the array. And number two, the space complexity will also take big of n space, because we are using an extra set. That is our we are using an extra space because we are using an another set. So this is the by this approach we can solve this problem in time complexity of big of n, and space complexity of big of n. And the second approach we can use two pointer approach. So how this two pointer approach will work? Let me tell you. So yeah, so we are going to solve this two pointer approach. In this two pointer approach, what we are going to do is we will compare every element. Like I will compare this nums1 with nums2. The if the element if nums1 element is less than nums of 2, then what does it means? That if okay, first of all, if nums1 is equal to nums of 2, then we have to return that element. Okay, this is the very best, very first base condition that we have to that we want to solve. Okay, so when n1 is equal to n2, then we have to return that element. If not, then what will we do? If n2 is greater than 1, it means that n1 is smaller than 1. So we have to iterate, we have to move this index to the right. And if n1 is greater than n2, then obviously we have to move n2, because this one is greater, and we cannot find the element smaller than n1, because we have to find the minimum element that is we have to find the minimum element that is common to the both the arrays. So this is the only approach that we can solve this problem. So this problem will also take big of n time complexity, but but the space complexity will reduce by big of one app. So, okay, let us move to the code. So, let me share you the code. Yeah, this is the code where we are using an unordered set, and in an equal when then we are iterating in the nums1 vector, and we are inserting it to the set, and after that we are just checking if the our set contains that element or not. If this element is containing our element, then we are going to return that element, or otherwise we are going to return -1. And the second approach, that is this one. This is a two pointer approach. In this two pointer approach, this is the condition we are going to iterate the while loop. While we are going to iterate the loop, this is the condition in which the element is not going to exceed the array. Like, we are not going to get the runtime error. So if nums of 1 of I is equal to nums of 2 of j, then we are going to return that element. If not, then we are going to increase, if nums of I is greater than nums of j, then we are increasing the j plus plus index, otherwise I plus plus index, and then we are going to return the -1. So both of these approach are completely acceptable in the lead code, but we are going to prefer the two pointer approach, as this approach save our space complexity. And yeah, so we are going to use this two-point approach. Two-point approach is the most optimized way to solve this problem. Thank you.